Hello, in this video we are going to study more instructions of the imaginary computer that we have been using in two earlier videos. And we are going to study a loop that is controlled and ends nicely. So this loop is different than the endless or this eternal loop that we studied in earlier video, and then we are going to study how to address data in the main memory of the computer. My name is Kari Laitinen, and let's take first a look at the program that we have already studied earlier. So we did study this program in an earlier video. So this program prints the text hello to the screen, and it does it just by using two different machine instructions. So this program works so that there is first, at the beginning, there is the instruction load register A with value, and then we give the value that is loaded to the register A. And in this case it is the character code of uppercase letter H. And then we use another machine instruction 9.2, and the meaning of this instruction is output byte from register A, and then this instruction then prints the character that corresponds to the value in register A. So this program continues this way, that always there is the instruction 1.5 load register A with value, and then we give the character code, and then with instruction 9.2 we output this character to the screen. So basically in this program we repeat for every character we have these 3 bytes or 2 instructions, and that way we print the text hello to the screen. And at the end of the program there is this one B2 instruction that stops the processor. So I would actually write this meaning of this instruction here, so it is stop processing. Like this. So I didn't write the entire program here because it is repeating the same instructions. So this would be quite easy program, but today we are then going to study a little bit different program that does the same thing. It brings the text, prints the text hello to the screen. But that program contains a loop, and it has more instructions, but it is a little bit shorter than this version of the program. So let's take then a look at the other version of this program. So we go first to the naturalprogramming.com, my site, and then we select this IC8 icon, and here we can activate the simulator. And the program that we are going to study is now this with name hello loop.iml in the simulator. As I have said earlier, I will later on explain what this IML means. So I will load this program, and you can see that it is now in the main memory. Maybe I will close this temporarily. So it is now in the main memory, and there are now new instructions there. Well, we can just start running this program. So I press the execute button. It starts fetching the instruction code, and if the instruction code is odd, then it fetches an operand for it. Now it is an odd code, so it fetches an operand, that is the next instruction in the main memory. So now the instruction is fetched. So now it is ready for execution. And what I have here a new page that you can find through this link. There is a table about these machine instructions, and we can see that this instruction is now 2.1. And here is an explanation for this instruction 2.1. The instruction is, so there is the instruction code and the operand that can be chosen by the programmer, and then there is this meaning for programmer, and then there is a longer explanation about how this instruction works. So this is now a memory related instruction, and so as this meaning for programmer says, it sets the memory pointer register of the imaginary computer. So that value that is given as an operand is now stored to the memory pointer register. So we can see when I continue the execution that the value 1A, so 0A, is copied to memory pointer. Now the instruction is executed. It fetches the following instruction 2.8. That is a single byte instruction. And now this is a little bit complicated instruction. So it says that it's copying 4.8 from memory to register A. So if we take a look at this explanation table, it is 2.8, instruction 2.8, it's load register A from memory. So it says here that this instruction copies 1 byte from the main memory to register A. The byte that will be copied will be determined by the content of memory pointer. So in this case, because the value of memory pointers is now 0A or OA, it will copy the value in address 0A to register A. So, and the value is 4.8 there. So this value will be then copied to the register A. And now it fetches the next instruction. Its instruction code is 4.5, and it fetches an operand for that because it is odd. So now the instruction is fetched, and we can check from this table that what is the meaning of this instruction. So it's 4.5. Its meaning is jump if register A0. So the explanation says here that this is another conditional jump. If the content of register A is 0, program pointer is loaded with the value that is given as an operand. But here we will see that register A is not 0, so register A has value 48, so it's not 0, and that means that nothing happens when this instruction is executed. So it starts fetching the next instruction. And that is 9.2. And that means that the letter H was output to the screen because its character code was in register A. So we have already seen this instruction in previous videos. So it's going to fetch the next instruction. And the code of that instruction is 2.2. So it's even. No operand will be fetched, and let's check what this instruction means. It's 2.2 increment memory pointer. So it means that the value or content of memory pointer is incremented by 1. So in this case, the old value is 0A and the new value will be 0B. And again, it starts fetching a new instruction. For 1 is the instruction code. It needs an operand. The operand is 0.2. So now it starts executing the instruction, and we can check again the table here. So it is jump to address. Instruction for 1 is jump to address. So these are hexadecimal numbers here. There is an H there indicating that they are hexadecimal. In the simulator there is no H's in use because it's always using the hexadecimal numbers there. So this instruction performs an unconditional jump in the program by modifying the content of register program pointer. The next instruction that will be executed after this instruction is the one that resides in the address given as an operand for this instruction. So now the operand is 0.2, so it means that it simply copies this value to program pointer, because the previous value is 0.9, which would be this instruction that follows this instruction. But here, with this, when the program pointer is modified, we can change the location from where the next instruction will be fetched. So it jumps to address 0.2. Now it fetches an instruction that has already been fetched earlier. It's 2.8, and again it copies a value from memory from that location that is the value of memory pointer register. Now the value is 6.5, and it fetches the next instruction. So the instruction code is 4.5. It is an odd code, so it fetches an operand. and this is the instruction that makes a jump if register A is 0. But register A is not 0, so nothing happens. And now it fetches the next instruction, which is 9.2, the instruction to output the content of register A. And so it outputs the lowercase letter e, because 6.5 is the character code of that letter. Now it fetches the instruction 2.2 and it increments the memory pointer, and the new value for the memory pointer is now 0C. Now it fetches the instruction 4.1 that needs an operand. The operand is copied from memory to the operand register first. And now, again, this is the unconditional jump, so it modifies the program pointer, and now the next instruction will be fetched from address 02. And again, it gets the instruction 2.8, and it copies a value from memory to register A, and now it copies the value 6C. And again, there is the instruction 4.5, and that needs an operand. It's copied to the operand register. And register A is not 0, so nothing happens. And again it fetches the instruction, and the instruction is now 9.2. And it means that the lowercase letter L is output to the screen as its character code is in register A. And again, the content of register memory pointer will be incremented by 1. And the next instruction is the instruction with the code 4.1, which is the unconditional jump to address 02. So it jumps to address 02. And now the next instruction will be fetched from that address, and we have already, I stopped it now, so we have already seen that what instruction is there. So you can see that it is repeating some instruction over and over in this when this program is executed. So let's take a look at how this program looks on paper then. I have written this program by hand on paper, so we can take a look at how it looks there. And what I have been doing here, so I have been using actually this table. So you can think that actually this imaginary processor here, so this big yellowish rounded rectangle is the intelligence of the processor. So you can think that this intelligence of the processor has this kind of table available, and always it checks when it gets the instruction code and optional operand, it always checks that what it has to do. So in this table I have always an instruction code and the optional operand. And the operand is sometimes a value, or it can be a memory address. And there is this meaning for programmer, and then there is a longer explanation for each instruction. So what I have been doing here, I have written these meanings for programmer here on paper, so that, for instance, there is this instruction to 1 set memory pointer. So here is the set memory pointer, and there is load register A from memory. It is the code 28. Like here, it's the code 28, load register A from memory. So I have written these meanings for programmer here on paper, so we can actually here try to understand this program on paper then. And what it really does is that it first sets the memory pointer to point the address 0A, which is now this location, and this location now contains the character code of uppercase letter H. And then it loads register A from memory and jump if register A0 is the next instruction, and then it would jump to this address 09 that contains the stop processing instruction. But nothing happens if register A is not 0, so it will continue to this instruction, which is the output byte from register A. So it outputs the character code of that character that corresponds to the content of register A. And then it increments the memory pointer, and then it jumps to address 02. So it always jumps to this address 02. So basically it repeats these instructions for every character that is given here in memory. And the key trick here is that we have the program has these character codes in continuous memory locations here, and it has the 0 at the end of all the characters. So the 0 here marks the end of character codes. And when we have this instruction jump if register A 0, so when there is a 0 here, the last thing it reads from the memory is a 0, and then this instruction takes effect and the program execution jumps to this address, and then the program terminates, or the processor stops. But until that, these instructions are repeated. These instructions are repeated over and over. So we can actually check this execution of the program, so that when it reaches this last 0 here, let's check that, because in this simulator there is this feature that you can click certain memory location, then it goes full speed to that location, and then it continues with a normal speed. So I will check this location where there is a 0, so it goes with full speed there, and it prints the text hello and the exclamation mark, but then it goes slowly. Now it copies the 0 from memory to register A, and then it fetches the next instruction. Now it is the 4, 5. And it needs an operand. So register A is 0. It jumps to address 09. And it fetches the code of instruction stop processing. And the processor is now stopped. So this way we end the loop nicely. So it is a controlled loop, not an infinite loop or endless loop. And we can make things we can make a lot of repetitions with this kind of arrangement. So so let's compare these two programs, because I have now two versions of the same program that does the same thing. So I have two versions of a program that prints the text hello to the screen. So the first version is we already saw that, and this version is now different. And if we compare these, so this shows first that there are many ways to write a computer program for to do a certain thing. So there is always many possibilities to write computer programs, and then we can discuss that what is the correct way to do a certain programming task. But in this, by comparing these two programs, we can do something. So, for instance, that if we, because the other program is here, so first we can see that because the last address of this later program, or the program with loop, is now 1, 0, and the last address of the earlier program is 1, 2. So it means that this our later program with loop, it is shorter. It is certainly shorter, but this is certainly very much this is simple program, so that we are using only 2 instructions here. We are using only 2 instructions or 3 bytes for each character that is printed. So this is actually quicker than the other version, because in this program we have actually we have 1, 2, 3, 4, 5 instructions for every byte or every character. So this means that this is certainly slower, this program with a loop. But this is shorter. And I think the biggest advantage with this program is that it is so in this program it's easier to maintain, because here the data, the text that is printed, is separated from the machine instructions. Whereas in this other version of the program, the data, the character codes, they are scattered here among the machine instructions. So if we need to modify this is going to be quite difficult. Or if we, for instance, want to make this program print some other text, it would be quite difficult to do it with this version of the program. But modifying this, it's quite easy, because here the rule is such that we just have the text after the last instruction. We have the text, and the text must be terminated with a 0. So if I want to make this program print something else than the text hello, it should be quite easy thing to do. So actually we can, to finish this lesson, we can try to modify this program so that it prints the text bye instead of text hello. So what I have to do is that I have to know the character codes of the letters that form the text bye. So I have here a link to the character codes table, so I can check that the character code for the uppercase letter B is 42. So I will modify this program, and I have to start from the last from address 0, 0A. So it was the character code was 42, and then the character code for lowercase y, it's 79. Goes here, and then the character code of lowercase e is 65. Well, let's put the exclamation mark there. So the character code for that is 21. And then I have to terminate the text with a 0, so I write a 0 here. So now it should print the text bye with an exclamation mark to the screen. So let's test it. And I will reset the processor, and I will execute, and I will put it to full speed. So it works. So it was quite easy to modify that, but modifying the other program would be more complicated, I think. So this was the program with a loop, controlled loop. So in next video we are going to study what a very simple programming language will be. And you could do some exercises with this. Maybe you could make this program to print some other text than hello or bye, or you could modify it so that it would print the characters of the text in reverse order. So thank you for watching, and see you in next video.